Alright, so I chose to do number 48, which is basically the one on the birthdays, where it says that there are 18 students in a classroom. The students are surveyed to determine their birthday, just the month and day, not the year, and to assume that there are 366 possible birthdays. Part A asks, what is the probability of any two students in the classroom of having the same birthday? Alright, so we're going to take the total probability of 1 minus the probability of I did the individual pairs probability to fail, which is, because it's going to be only one matching one, to the power of the number of pairs, and the number of pairs is I write it like this, the total number of students, which is 18, times the total number of students minus 1, so 17, over 2. So what this turns out to be is 153. So you have 1 minus 365 over 366 to the power of 153, which turns out to be, as you can see right here, 34%. If you write it as a percent, 34.204, let's say, percent, that two of them will share a birthday, which is quite surprising. But you know, if you think about it as not one person, but any one person out of the 18 sharing it with any random person, it seems more likely. Alright. Part B says, write an inequality that can be used to determine the probability of any two students having the same birthday to be greater than 1/2. Alright, so this is basically, our variable is going to be the number of students. So it's going to be very similar. The total minus 365 over 366 to the power of, let's use x. X times x minus 1 over 2. That's the power, is equal to, and that's an inequality, so it's greater than 1 over 2. And then part C asks, are there enough students in the classroom to have the probability in part A to be greater than 1/2? If not, at least how many more students would there need to be for this to be true? So I'm going to kind of put a calculator. It's going to be 1 minus 365 over 366. I have a feeling we're going to have a lot of parentheses. To the power of x squared minus x, just FOIL it, whatever, over 2, parentheses match up. Alright, actually that wasn't that bad. Let's look at the table. We want to see when this is greater than 1/2, or 0.5, which is at, well, greater than it's at 24. So you're going to be closest to a 50% on a pool of 23, but really if you want it to be greater than, it's going to be 24. Alright.